Let's look at example 2 real quick, or second example. Again, remember the steps. Identify the slope of each graph. And then from after identifying the slope, we'll find the y-intercept, write the equation, and restrict the domains. First graph, look at the purple one. On our slope, we can see that the slope here is going to be, pick any 2 points on this graph. It looks like the slope is up 1 over 2 to the left. So my slope is m is equal to up 1, 2 to the left, negative 1/2. On this red graph, again, pick any 2 points. Here and here will work. Looks like it's up 1 or up 2 and over 1. So my slope is 2 over 1 or just 2. We can see the y-intercept from the red graph is easily seen to be b equals 1. And for the purple graph, continuing the slope, which was, this time we're going to go down 1 and over 2. So when we do that, we see that the y-intercept is going to split this in half like that. And we can calculate the actual y-intercept. Because this isn't a nice point that we're going through, we're going to calculate it using the actual slope-intercept formula. Slope-intercept formula says that y equals mx plus b. And that should be true for any point on the line. So let's take any point that's on this line. Let's take this point right here, which is a point -1, +3. And we're going to plug in, here's your x and here's your y. We know x and y, and we also know our m is -1/2 because we found that already. So the only thing we're missing is b. So we can solve this equation for b. So to do that, we get 3 is equal to m, which is -1/2, times x, which is -1, plus b. Calculating this, we get 3 equals -1/2 times a -1 is a +1/2 plus b. And I'm going to subtract 1/2 on both sides. When I do that, 3 minus 1/2 is 2.5, or 2.5 is equal to b. And that's about where this point is at 2.5. So we know that the purple b, or y-intercept, is 2.5. And from there, we can write the equation for the piecewise. F of x is equal to -1/2 x plus, plus 2.5 for the purple, and 2x plus 1 for the red. The last part is to define the domain of the function. So for the purple function, we can see that the domain goes from, well, it starts with an arrow, and that means that it's -infinity. And it's stopping, and let's clear up some of the graphs so you can see everything on the graph now. It's stopping right here at 1. So it looks like it's every number that's less than, -1. It's like it's every number that is less than -1. So for this, we write that as by saying x is less than, and notice again it's a closed circle. So this is a closed circle, which means we can equal that number. X is less than 1. The other one says, well, to make this continuous, look at what you have down here, an open circle at 1. So we're not going to include 1, but then it has 1 going to an arrow this way, which is all the numbers or anything bigger than -1. So we're going to say x is greater than 1. And here's the actual piecewise, defined by the 2 lines and their domains.